Okay, today we're looking at the notes for linear measure, distance, and midpoint. First, we're going to talk about a few of these parts. First, we're going to talk about a line segment. A line segment is measured by the distance between the two endpoints. It's named by its endpoints. For example, if I have the points E and F, then I would call this segment EF. You also could see this segment written as segment EF with the segment symbol above it. Congruent segments. Two segments are congruent if they have the same measure. Alright, the betweenness of points. Point M is between points P and Q if and only if P, Q, M are, obviously they must be collinear. And also PM, segment PM plus segment MQ equals segment PQ. So we're saying that M is between P and Q if PM plus MQ equals PQ. Alright, which actually I just did over there. You actually have that segment already written, and we put M inside of there. Okay, looking at this next one, let's move that up. Right here we have find LM, so we're looking for the length of this segment here. Well, if I use that formula of betweenness, then LM plus MN is going to be equal to LN. Well, LM is what I don't know. That's my variable. We're adding, that's this distance right here. MN is 2.6, and LN, the whole length, is 4. And now I solve it like an algebra problem. And we get X equals 1.4 centimeters, which then I can say that LM equals 1.4 centimeters. Alright, looking at this other problem, find the value of N and WX if W is between XY. So we've got W is between XY, so I've got X here, I've got Y here, and W is between it. WX, this length is 6n minus 10. XY, that's the entire length, is 17. And WY, which we'll use this blue, WY is 3n. So basically what I'm saying here is this length plus this length is equal to this length. So I take 6n minus 10 plus 3n equal that to 17. Now I'm going to solve for my variable and then replace my variable into WX, this right here, to find the length of WX. So I end up with 9n, add 10 to both sides, and I end up with this divided by 9. So n is equal to 3. So there's my n. And then I'm going to plug that into WX to find WX. So I'm going to say 6n, which instead of n I'm going to put 3, minus 10. So 18 minus 10 is equal to wx, which is 8. And that's my solution there. Okay, looking at the bottom page of these notes, the distance formula on a number line is the absolute value of the difference between the coordinates. For instance, if I take coordinate q, which is negative 6, and I subtract my other coordinate, which is negative 3, the absolute value of that is my distance between q and r. Well, that ends up being negative 6. When I subtract a negative, I'm adding 3. And negative 6 plus 3 is negative 3. Well, the absolute value of negative 3 is 3, so that is my distance between q and r. What if I did these backwards and I started with r? And I said, okay, negative 3 minus my q, which was negative 6. Well, we would have negative 3 plus 6, since subtracting a negative, and that would leave me with the absolute value of 3, which is still 3. So it doesn't matter which one I do, the absolute value still gives me the distance. Alright, let's look at the next page. Okay, find the distance between points A and M. Well, this isn't so easy because it's not a straight line. I can't do that. But what I can do is I can use the Pythagorean theorem to form a triangle. This length is 2, this length is 4, and if I'm using the Pythagorean theorem to do this, that length is my x. So the Pythagorean theorem is a squared plus b squared equals c squared, which a is 2. Remember, the legs can be interchangeable, so we're going to pick 2 to be a and 4 to be b. 4 plus 16 equals c squared. 20 equals c squared. We take the square root of that, and if I simplify the square root of 20, I get 2 radical 5. So that is the length of AM. Right there. Okay, now they've given me 2 points. I don't have the drawing, I don't have this graph, I have just 2 points to find. Besides using the Pythagorean theorem, there's another method that I can use, which is the distance formula. You'll remember the distance formula as x1 minus x2 squared plus y1 minus y2 squared. And whatever, it doesn't matter which x I pick first, as long as I choose the same y to be first in that section. So for this one, we'll just call this x1, y1, x2, y2. So we're going to plug these in to our formula, and I'm going to actually shrink this and work this over here on the side. So we take the absolute value of x1, which is negative 4, minus x2, which is 3. And we're going to square it. Then we're going to add y1, which is 1, minus y2, which is negative 1. And we're going to square that. Okay, so negative 4 minus 3 is negative 7 squared. Plus 1 minus negative 1 would become plus 1, so 2 squared. So negative 7 squared is 49, 2 squared is 4, and we end up with the square root of 53. We will see that there is no way to simplify that, so the distance between those 2 points is radical 53. Okay, I'm going to go ahead and zoom back into these. The midpoint is the point halfway between the endpoint of a segment. The midpoint formula, you'll recall, is where we take x1, basically we add the x's, divide it by 2, and we take the y's, and we divide it by 2. Okay? So for our first example, we're going to find the coordinates of M, the midpoint of G and H. G is 8, -6. H is -14, 12. So again, we're going to pick this first one just to be x1, y1, x2, y2. It doesn't really matter which one you use. So I'm going to add the x's, which are 8 and -14. So, sorry about that. 8 plus -14 divided by 2, and that's my x-coordinate. And then y1, which is -6, plus my other y, which is 12, divided by 2. So 8 plus -14 ends up being -6 over 2, which is -3. And -6 plus 12 is 6 divided by 2, which is +3. And that is the midpoint of that segment right there. Okay? Find the coordinates of D if the midpoint. Okay, so we've got a segment, and this one's a little different because we're saying that E is the midpoint of DF. E is the midpoint. E is -6, 4. F has the coordinates -5, 3, -3. Well, this is different because I don't have the endpoints. I have one endpoint and a midpoint. We can still use the formula to solve this. What we do is we take what would be x1 and we add it to our other endpoint, -5. We divide it by 2, and that's going to equal this x-coordinate, -6. So how do we solve that? Well, to get rid of the fraction, we multiply by 2, and we end up with x plus 5 equals -12. Subtract 5, and we end up with x equals -17. So that's the x-coordinate. I'm sorry, I did something wrong there. It was -5, so I should have added 5 to that to get rid of that. So let me change this. This should have been x minus 5 equals -12. So when I add 5, x would equal -7. Okay, and I'm doing the same thing with the y's. I'm going to take my y that I don't know, add it to my y I do know, -3, divided by 2, and set it equal to what is the midpoint? 4. Multiply both sides by 2, and I end, 2's cancel out there, and I end up with x plus -3 equals 4 times 2 is 8. Add 3 to both sides, and x equals 11. So my endpoint is going to be -7, 11 as my answer, because I got my x value there. I'm sorry, this should be y, and my y value here. Okay, continuing with the notes. Any segment, line, or plane that intersects a segment at its midpoint. That's what a segment bisector is. What does a segment bisector do? It cuts the segment into two equal parts. Okay, so if that's the case, let's look at this problem here. What's the measure of PR? PR is the whole segment right there. If Q is the midpoint of PR, so this point Q splits this whole distance in half. That means that this length times 2 is equal to this length. So I'm going to take 6 minus 3x, and I'm going to multiply that times 2, and whatever I get, it's going to be equal to the full length, which is 14x plus 2. Then it's just an algebra problem. 2 times 6 is 12. 2 times negative 3x is negative 6x. Isolate the variable, so I'm going to add 6x here. I'm going to subtract 2 here. I'm going to end up with 10 equals 20x. Divide by 20, and x equals 1/2. Is that my answer? Well, it asks what's the measure of PR. So now I have to go back to PR, which is this value right here, and instead of x, I'm going to put the value of x, which we found to be 1/2. 14 times 1/2 is 7, plus 2 is 9. That means segment PR equals 9. Okay, and that's all the notes for this lesson, which is linear measure distance and midpoints.